25th, 25. Yeah, bless you. There are three methods for solving systems that we teach at this level. There are other methods as you advance through crazy harder mathematics classes. Even in Algebra 2, we'll show you how to do it with matrices. But there's three that we hit hard in Algebra 1. One of them you should have already mastered. Assuming I didn't even look, assuming you're done with assignment 36, like I just didn't even check. I assume you're all great people and followed directions and got that done. So that system, that method is called graphing, like, and it's just, it is what it is. You graph two lines and see where they cross, right? These other two methods that we're going to learn over the next week or so, these are the, you don't have to know this, but they're called the algebraic methods. There are two of them that we teach. And what we mean by that is there's no graph involved. When we talk about something being algebraic versus graphic, um, the algebraic nature of it is that no graph paper, no lines, no slopes. It's just all X's and Y's and playing around. So if you're a mathy person who likes X's and Y's and the process of, uh, solving for things and moving things around, then you'll really like the next week or so. Um, uh, I think like this, when I rank, you do this long enough, my ranking is 100% set in stone. My favorite method is the one that we'll learn next, probably Tuesday or so. That's elimination. The one that we're going to do today is definitely my second favorite. I don't like graphing, so graphing is my third favorite. Like I'll do it if I have to, but I would much prefer the algebraic methods because I like just moving X's around and playing with numbers and letters and stuff like that. So I much prefer these methods. Anyways, today's is the second of the three, and it is called substitution. And I have four examples. First example, you'll kind of go, yeah, okay. And then by the time we hit like example 3, you'll be rolling. You'll be good to go. So I'm gonna put the system up here and I'm gonna show you how to solve it. And then as we go through the lesson, I'll try to give you a little bit more, like probably starting on example 3, I'll give you a little more space to try it on your own before I chime in and get in your business. So 2x minus 3y equals 5, and 2x plus y equals -7. Sometimes you'll see systems written like this. Sometimes you'll see systems written like this. Sometimes people put a little curly bracket around the outside to sort of represent that they're holding something together as a system. The program that I use often won't, I don't think, put the curly bracket on there. So your assumption is obviously that you're working with a system, but just be it known that you will assume that it's a system just based on the structural nature of it. So again, when you see that bracket around the outside, that's just someone, maybe it's a textbook, maybe it'll be on a test that you take like the YTOP or the ACT or something. So don't think that that bracket means anything other than just someone's trying to tell you it's a system. Again, some people don't put it in and they just tell you it's a system and then you know what to do. So let's get to it. This process is, you might like it, and you'll be interested. I'll be interested like in a week to get your feedback. Next Wednesday or Thursday, I might ask you like, what do you prefer? And I usually find about 80% of students prefer the one that we'll learn Tuesday, Wednesday. And then there's about 20% who like today's the best. Some people fall in love with this method. So anyways, the way this works is, and step 1 is critical. You're awake and alert, I hope. So if you hear 3 things I say today, please let this be one of them. Look at the 4 variables. And I know that you might say there's only 2. There are 4, right? There's an X, a Y, an X, and a Y. If I asked you to solve for one of them, like a literal equation, like get it by itself, it's a no-brainer. Of the 4, which would be the easiest to solve? Yeah, and bottom y. So we want to be clear when we talk and say like top x, top y, bottom y. And I assume you meant the bottom y, correct? Why is the bottom y going to be easy for us? It doesn't have a number with it, does it? And that's going to save me a lot of stress, because if something has a number with it, like if I said to Hagen, hey, solve for the top y, I don't doubt for a second that he could do it. But the trouble with that is at the end of him getting the top y by itself, he'd have to divide by 3 or -3, depending on his approach. And when you divide, you create that F word called fractions. So if I can avoid that, I want to. And I'm telling you straight up, as someone who cares about you, this first choice that you make is critical. So I'm going to say it again. Which of the 4 is the best? The bottom y. So our target, and by the way, when I ask you to do substitution, I will always give you one, at least one, that's more attractive than the others. So when I put this one out there, my assumption is after today, you'll look at this and say, I'm solving for the bottom y. This is not a choice. There's no, like, you don't want to flex and say, well, I can do it with the bottom x. You go ahead, but I mean, why make life harder than it needs to be? So our mission in step 1 is to pick the right variable and get it by itself. So what I'm going to do is draw a little arrow off of this equation, and I'm going to solve it for y, for reasons you'll soon understand. Now, if I were to get that y by itself, we're almost to February. Like, you got this. If I said get that y by itself, you go, oh, okay, I think I can do this. I would leave the y where it's at, and I would move the 2x. And when I move the 2x over the equal sign, this is the 1,000th time I've said this, we switch the sign. And so the 2x relocates himself to the right side and becomes -2x. Simple enough, right? The -7 didn't have to move. He moves a little bit to the side, but that doesn't really count. So the -7 just kind of scooches over and makes room for his new friend, -2x. Any questions so far? Okay, get used to this. Some people do this, some people don't. You'll see me do it. I'm every time. If you could go back and watch me teach this lesson 14 years ago, like in some kind of weird time machine video recording device, you would see that I'm going to draw this red box. I always have, and I always will. I believe it helps us to kind of like have something throughout this process to hold on to. So what I'm going to do is I'm going to put a red box around everything on the right side of the equal sign. And I'll tell you why that is here in a second. That white and red equation up there in the corner is pretty cool. What he says is basically, I'm giving y a new nickname. I'm giving you the green light, permission, whatever you want to call it, to say that from now on in this problem, whenever you see the letter y, you can call him by his nickname. And his nickname is -2x minus 7. An equation in math says that this is the same as this. So y basically lays himself down and says, from now on, my name is y, I know that, but if you run into me like at the store or whatever, feel free to call me -2x minus 7. I know that sounds pretty weird, but the idea is that I've now given y that alternate name, which means I can go find another y somewhere else in the problem and call him by his nickname. So follow this red arrow. It's going to go like this. Right there, I see another y. And take note, mental or otherwise, of the fact that I did not go and find the y that was in the bottom equation, because that's the one I used to make the box. So you always have to pick the other one. Trust me on this one. If you pick the same one, you'll always get the wrong answer, because it'll come out to an identity, which, trust me, it's just, yeah, it's not sensible. So always go to the other equation, the one you didn't tinker with, and plug the red box back into the letter that you solved for. It's going to look like this. So if I take the top equation now and I rewrite it, what I'm going to do is I'm going to rewrite it, but when I get to the letter y, I'm going to leave room so I can substitute. This is where it gets its name. I can substitute the nickname. So I'm going to write 2x minus 3 awkward void equals 5. Remember, that's where y used to be, but y gave us permission. He said, if you see me at King Soopers, feel free, it's between you and me, call me -2x minus 7. Yeah. So instead of y, I'm going to put into that awkward void the nickname. negative 2x minus 7. And that's a tremendously powerful and beautiful moment, because what happens is now I have an equation that since about the second week of September, we all know how to solve. That statement is of course predicated on the assumption that you know how to distribute negatives and combine terms and stuff like that. But we've been doing this all year. So what I'm going to do now is solve that new red and white equation at the bottommost part of the TV. Here we go. So it's 2x, and then I have to distribute that negative or minus 3. What does this become? You bet, it's plus 6x. And what does this second white arrow here become? Yep. The substitution nature of this problem is not even really in existence right now. Right now, we're just kind of off on a side quest, right? So now I'm going to continue. I'm going to combine my like terms. I'm going to put my 2x and my plus 6x together to make 8x. And we'll go faster through these steps as we head through the day in the next couple days. But I'm just showing as much work as I can. What's next? You bet. Subtract that 21 across, and so I'm going to get 8x equals, and these are the things that drive people like me nuts. If anyone over the age of 12 struggles with 5 minus 21, you can see that that takes a toll on our ability to function together. What is 5 minus 21? It's negative all day long. Negative 16. Good. You see how crippling it is when someone says 16. It's like, what are you talking about, man? And then we divide both sides by 8, and we get x equals negative 2. What we now know is that the answer to this problem, and I'm going to very purposely switch colors here. I'm going to be consistent with my use of colors throughout this lesson. I now know that the answer to my problem is that these lines, if I graphed them, these equations will cross at an x coordinate of negative 2. That's what x equals negative 2 means. I found half my answer. This is the part of the lesson where I always say this. We have found 50% of our answer, but we've done like 90% of the work. We're almost there. Do you remember the red box that we drew about 2 minutes ago? He's your friend now, because not only was he the thing that we physically picked up and substituted into the other equation, but he's now our jackpot simplest place in the world to find the value of y. So I'm going to scroll back up here and show you that red box. Remember that? It's just like one-stop shopping. It says y equals this box. And so if I want to know what y is, look how easy this is. I could just take this negative 2, and I'm going to move this back here in a second, but I'm going to see if I can move the negative 2. I don't know if I actually can. Look at that. I could take that negative 2 and put it right there in place of x. You see that? And if I put that up in place of that in the box, all I got to do is like some 5th grade math to figure out what my y is. So I'm going to do negative 2 times something minus 7. I'm just plugging it back into the box. And again, what goes in those parentheses? Whatever x is, negative 2. And then again, we hope you can do basic math. What's negative 2 times negative 2? And what is 4 minus 7? Therefore, these two lines cross at the point negative 2, negative 3. Done. So you're on a scale somewhere right now of 1 to 10. 1 is I have no idea what in the world just happened, and 10 is like, I got that. That's easy. So I hope you're closer to the 10 side, but that's how you do substitution. All right, first one's always the hardest. Let's go again. All right, second example is x plus 6y equals negative 4. Second equation in the system is 6x plus 7y equals negative 24. Right away, if I've done my job and you've done your job, who right away has your attention? Top X. If you don't love top X, I failed you in that first part of the lesson. Of the 4 variables, he's the one that says, I don't have a number with me. Pick me, for God's sake. Because if you try to get me by myself, all you got to do is move this pesky 6y out of the way. Easy. So we're going to take that equation, the top one, and we're going to solve it so that x is by itself. What will it say when x is by itself? Absolute perfection. And I being who I am. And I don't do this because I like drawing red rectangles. I do this because for me, it has always felt like it helps. It helps to draw my attention to that box because I need that box twice. The first time I need it is right now when I'm going to take the quantity inside that red box. And where am I going to put it? Who is the red box? What is the red box? It's X. There you go. Now that's what I wanted to hear. Don't read to me what's in the box. That red box is X. That's what that equation says. The box says, I am now X. When you see X, call it this, me. So I'm going to take the contents of that red box and I'm going to put it in place of X, but I am not going to make the rookie mistake of putting it in the top X because I already used that equation. I'm putting it into the bottom X. Whichever equation I didn't use is the one I have to resubstitute into. And now I'm going to write that equation again, and it's going to say 6 awkward void plus 7y equals negative 24. I always put the awkward void and just keep writing the whole equation because I find sometimes, not just me, but kids also, if I start putting things in, then my eyeballs kind of lose their focus. And I might erroneously, it happens all the time, when I come back to writing the rest of the equation, my eyeballs might slip to the top one and I start writing part of that. So I just plow through and write the whole equation, 6 blank plus 7y equals 8. And then I go back and I fill in the red box. And what's going to go in the void? And from here on out, it's just a little simple problem. It should be. It's not. Sorry. Should be. I get paid. You know, you don't do this for free. And one of the biggest things that's on my to-do list, and I meet ninth graders every year, 70 new ninth graders every year. And what my priority numero uno is, can I get these kids to solve equations? I mean, I got 100 things I want you to learn, but number one is, can I get them all to solve equations? You should be good at this. What do we do first? You bet. And what do we get? Now, I'm going to skip a step this time just to see. I'm going to test the waters. If this makes you crabby, then you could see that maybe you're not someone who's ready to skip steps. But I'm going to do two things at once. I've done this before. And so here it goes. Let me know if you don't like this. I'm going to put negative 29y equals 0. What two things did I do? I did. I combined the like terms on the left, and I know that negative 36 plus 7, you know this too, is negative 29. And then I added the 24 to the other side, which made a 0 when I added those two numbers together, right? And now I just divide by negative 29. And, you know, I get this question a lot, like, oh, what did I do wrong? It's like, nothing. Quit picking on 0. People always hurting 0's feelings. When you divide both sides by negative 29, 0's just a guy, right? So you just get y equals 0. You know, it's not like the end of the world. 0 gets his feelings hurt like millions of times in this country every day because kids are like, I must have done something wrong. It's like, no, 0 is no different than 3's and negative 2's. Quit picking on the poor guy. So I'm going to switch to yellow, and I'm going to now state for the world that my final answer has a 0 in the y spot. And where am I going to put that 0? Where's my path of least resistance? In the red box, right? And so I'm going to take that 0 and I'm going to go back to my friend, to Mr. Red Box, bless you, and I'm going to change the y value into 0. So again, the 0 will go follow the arrow right there. And I don't think I need to show any work on this one. Like on a test, I don't understand if you didn't show work on this because this is easy. What's negative 6 times 0? What's 0 minus 4? 0 minus 4. Negative. Done. Okay. That one feel a little better? Maybe you went from like a 3 to a 7 on that one, or a 5 to a 9 or something like that. All right, I'm going to put this one up here and I'm going to give you a little more space this time. So I'm going to kind of rely more on you to get the ball rolling. Do a couple more. I gotta find my, there it is. Let's do negative 8x. And eventually we will do these, the ones that have no solution and infinite solutions, but I like to just kind of leave all that out until we're really good at all the mechanical stuff. So I don't want to gum up this lesson with funky stuff. All right. The only guidance I will give you is the very beginning. Now, you might be physically more attracted to two of the variables, but one really is better. Who's our guy? Yeah. And if you fall for the old trick and say, well, what about the bottom y? My answer to you is going to be why? Why are you doing that to yourself? The bottom y has a negative, and then I got to move him and move another guy. Like, why not choose the path of least resistance? So I'm going to cut myself out of this for a minute. You guys, please choose the top y and go ahead and proceed. Let's see how you go. See if you get stuck. I'll pause this for a sec while we work here. So this is what step one should have looked like. You might want to take a glance and make sure you're at least on the right track. So we're all picking the top equation, and we're going to say y equals positive 8x plus 18. Everyone take a quick peek at the TV and make sure that my red box and your red box match. Good, good? Okay. Where are we putting that red box? Bottom Y, that's what we need. We always got to say top or bottom so we communicate well. Bottom Y is going to be the recipient of the red box. All right, you should be done with that step by now. So the red arrow up here will indicate where we're going, and that red arrow points to right there. So again, here in a moment, take a peek at the TV and make sure that you and I are on the same page. The bottom equation now says this: negative 7x minus awkward void equals 12. The awkward void should always be represented with parentheses because parentheses will force us to do distribution. So don't think that I just like parentheses. What's going to go in those parentheses? Or for you guys, you already did it. What went in your parentheses? Good. And what are we going to distribute through those parentheses? Good job. So let me get caught up to you. I'm assuming you've gone this far. We should all have negative 7x minus 8x minus 18 equals 12. And here I go again, Mr. Speedy Pants. I'm going to skip a step. I'm going to do two things at once. Put my x's together. I get negative 15 of those bad boys. I'm going to add 18 to both sides, and I'm going to get 30. If you don't want to do two steps at once, that's okay. Y ahora tenemos que dividir los dos lados por negativo 15. X igual a negativo 2. We all agree with that? Okay. So at this point, again, you see what I mean now, and I said this before, that we've only got 50% of our answer, but we really have at this point done 90% of the work. So negative 2 can replace x, and where are we going to put that precious negative 2? Into the red box, right? The red box is your homie, man. Not only does he substitute in step one to get you by, but then he sits there and waits like a beacon and says, you can use me as your substitution guy at the end. I'm the easiest way to go. So if I take negative 2 and I plug it back up into this x, follow the arrow, whoop, what's 8 times negative 2? And what's negative 16 plus 18? All day long. That's how you do substitution. Okay, this time I'm going to bow out completely. This will be one, I'm going to put it on the board, and I'm not going to help you at all. The only thing I will do is when you think you finished the problem and you get like my yellow answer, you're done, You say it out loud, and I want to write it on the board. And I mean, wouldn't it be amazing if all 20 of us got the same thing? But that's often not the case. And so if Jackson says like I got 3-4, and Ryan's like I didn't get that, then Ryan's going to give me his answer. We've done this before. I just want all the answers so we can see how we're doing. All right, last one. And then we'll work on our on a worksheet, like a homework assignment. Make sure you have that copy down. I'm going to pause the recording, but I'm also going to head over and print. I'm going to make paper. You guys like paper copies better, right? I'm going to print the assignment here at my printer and get you guys paper copies of today's works. 11 negative 1, is that what you said? Okay, so we have an answer. The game has begun. 11 negative 1 has been volunteered. Jess, you got an answer, bud? Oh. Jesse thinks it's -3, 0. On our worksheet today, are we going to get fractions, or will we never get fractions? No, they're all nice, just like this. Someday you'll get fractions. I never like to start with bad stuff because then we focus not on what we're trying to learn, but on the annoying stuff. So, like I said, once we master this and we hardly even have to think about it, we just cruise control through it, then we'll start sprinkling in trickery. Landon, do you not like your answer anymore? Would you like me to remove it from the television? Okay. So Landon's answer has been unsubmitted. Someone else gets it, then I'll get rid of that purple slash, I guess. Of course, yeah. I just want answers, bro. Brando, what you got, buddy? Oh, good. Okay. Good. So -3, 0 seems to be a pretty hip and trendy answer at this point. Okay. You think it's 5 -1? Okay. I'm going to go ahead and I guess we'll just remove this one. Any more still coming in? All right, so I'm not going to time myself on this, but really you should be at a point, if by the end of this assignment, like by the time we're done on Monday probably, you ought to feel like you look at one of these and you go, this is going to take me a minute, right? So here goes the process. I'm going to take the top equation and I'm going to get x by itself, and it's going to be x equals -8y minus 3. I'm going to box that sucker up, and I'm going to put it into the bottom equation in place of x because I didn't use the bottom equation, and it's going to say 2 blank plus 4y equals 6. And then I'm going to backtrack and go fill in that blank with -8y minus 3. Now, when I solve this equation, I'm going to get -16y minus 6 plus 4y. And again, here I go doing a couple different things at once. I'm going to combine my like terms, which makes -12y. I'm going to add 6 to both sides, which is going to give me 12. And that definitively is going to tell me that y has to equal -1. So we know at least that the y coordinate is -1. And now, of course, to solve for the other half, we're going to just simply take that -1 and pop it back up into the red box. Just right there. What's -8 times -1? And what is 8 minus 3? 5 -1 is definitely the winner. Unless there was a boo-boo. How many of you got 5 -1? For those of you that got -3, 0, do you see where you went wrong? because that's kind of important in this line of work, is to sit there, and it's okay. Like, you should know this about me by now. Until the day of the test, making mistakes is fine, right? What's important is that you look at it and want to know where you went wrong. That's the kicker. -30 was a pretty hot answer, it sounded like. So I hope you guys all who got that spotted. Uh, can I help with anything or explain anything on that? By the way, I wanted to show you one more thing before I cut the recording. If we make this claim that this is the answer, and I'm telling you this, and I tried when I was younger and silly, like 27 years old, ready to conquer the world, new teacher. I was like, you have to check your answers. And I realized that, like, that should be a personal choice. So let's say you're taking a quiz in like 2 weeks and you want to know if you got a perfect score. Here's what you can do. You can grade your own paper. You ready for this? If we claim that the answer is 5, -1, then I should be able to put a 5 right in place of that x and a -1 right in place of that y, and the equation should check out. You see that? So if I put 5 in place of x and -1 in place of y, it'll say 5 plus 8 times -1. And does 5 minus 8 equal -3? It does. So I'm going to put a check mark next to that. But that only means that the point is on one line. That's not good enough. I need to do it again. So now I'm going to go to the second equation, follow the green writing. I'm going to put a 5 right here where this x is, and a -1 right there where that y is. Right here where I'm wiggling my pen, what's 2 times 5?
10.
And what is 4 times -1? And is 10 minus 4 equal 6? I just proved that this has to be the answer because its x and y values actually work in both equations. So, see it? Okay. Recording is going to end. I'm going to hand out the worksheet. You guys have about 16 minutes. You ought to be able to get, I don't know, 3, 4 problems done. We'll see.